Okay, so hello, my name is Martin Dupras. I study here. I'm a second-year PhD at the OU. And what I want to talk about is essentially the project that stems out of the question that is my research question, but is really what I want to know. How can we program computers by playing the electric guitar? So there's a sort of rationale and background to this, because I'm a guitar player, I'm a composer, studio owner, sound designer, I've done many things like that, and my life doesn't constitute a collection of disparate things. I am all of these things at once. So I want to bring in various places the things I can do. So as guitar players, the culture has evolved such that effectively the sound is part of what it is that we play. So we play with guitar pedals and we play with various techniques that make the sound really quite important. And the current practice, generally speaking, is that the guitarist will go through a bunch of guitar pedals that are ways to change the sonic palette, and that we manipulate this in real time, usually at the same time as we are playing, which means that effectively we have limited ways in which we can control those sound processing mechanisms. Alongside that, what guitarists do are kind of separated between the things that we do in real time and the things we don't do in real time. So the real-time things are quite obvious, playing and engaging with an audience and improvising and all of that stuff. But there's all of the stuff that we do in non-real time that is part of the practice. So composition and recording and arrangement and sound design and programming effects and putting a pedal board together and all of these kinds of things are things that we do that are part of the practice. But we can't bring all of the elements of that practice into the live environment. So in effect, there are some elements of answers that exist in various places. In live coding, and this is not, it's just one image that illustrates, it's not partially significant here. In live coding, what we do is that we take to the stage something that didn't belong to the performance space, and we turn it into a performance thing. And when we do that, we change the nature of what we do with it, what we program, the kind of ideas that we have, and the music that emerges out of that ends up being different. And we have things like the stenophone, where somebody thought, well, the QWERTY keyboard is not expressive enough. Can we take a text entry device and make it more expressive by adding continuous control? And we have the cold clavier, where somebody thought, well, if we have a MIDI piano and we listen to what the MIDI piano is doing, then what we can do is detect some patterns and make those patterns call up programming constructs. Those are not immediately useful in the sense that in the cold clavier, for instance, we hear the piano all of the time, which means that effectively the programming constructs need to be musically meaningful, which means that effectively, well, we are limited to things that work in that particular thing that we are playing. And with the stenophone, well, I'm not a stenotypist with years of practice of doing that. I have years of practice of playing the guitar. Not necessarily well, but I've done that for many, many years. So what I would like is to tap into the skill set that I and other guitarists have developed over the years and see if we can turn that into a very efficient, very expressive interface. So we have some design constraints that come with this. Because in order for this to be useful to me and to other guitarists, that needs to be a real-time thing. It can't really have any amount of latency that means that we do something and then we wait for something to happen. So there needs to be the idea that sometimes we are playing and sometimes we are very quickly entering into a programming mode to make the computer do something. We need to allow musically meaningful output, because if this means we can't play the guitar or do all of the things that we like as guitarists, then it's kind of a little bit pointless. It needs to offer new possibilities as well, which is quite important because many of the things that have been introduced in the arsenal of performers have changed the practice. If we think of the wah-wah pedal and the vibrato bar and the slide and all of these kinds of things, they yield their own sets of music literatures and bodies of work. And we need to preserve the instrument's expressive potential. Here, the reason that is there is because there are many things that exist that allow the guitar to interface with a computer, like MIDI synthesizer systems, but where you can't bend a string, or you have to play very, very precisely because it doesn't track otherwise. That becomes too limiting, and there's lots of performers that refuse to engage with a system like that because they're saying, well, I just can't play freely what I want to play. So the problem space that creates for us starts from a position that, well, we need to have a sort of initial paradigm about how are we going to do this kind of stuff. So the paradigm that I'm employing here is that effectively I press a foot switch, I play something, and then when I press a foot switch to enter another mode or to exit that mode, then I go back to playing. Which means that effectively we have these little moments of entry, which also means that effectively I could enter something, go back to playing mode, enter something else, go back to playing mode, and then eventually that can be the program. So what else do we need to figure out? Well, we don't have a pointing device and keys because these things need hands. And doing that with feet is not really, is not very useful. But the guitar and many polyphonic instruments have a lot of capability to give us lots of levels of information. So one of the things is we can have relative information. If I play something in one place and I play it elsewhere, it can have the same structural information. So in terms of relative information, that gives us some flexibility. I can have simultaneous values. If I play a chord, I have various values at the same time. I have access to timing, so I can enter temporally significant structures. Intensities, durations are all things that give us different layers of information that can be happening all at once. So in one performing act, we can have many of these different levels of simultaneous data structures. So the current prototype that I have for a system that aims to do that is one in which I've equipped a guitar with a hexaphonic pickup system so that each string is output individually and then being input into a low latency interface and then going into a pure data patch because I'm a PD guy. And then in the PD patch, I'm doing quite mundane stuff. I'm doing pitch estimation, onset detection, amplitude contour. And with all of these, I'm doing simultaneously different levels of that. So I'm doing pitch detection over the very short term, but also over the longer term. So I have kind of like cooked and raw versions of these different parameters so that they are always there, but different algorithms can access the ones that they need at any given time. So basically, what we're doing at that point is more or less what is being done in guitar synthesizers, with the difference that we don't have to convert into something that is a symbolic system as such. When we have a MIDI guitar system, we need to drive some other MIDI devices, so we have to adhere to that protocol. Here, I'm doing kind of the opposite. I'm extracting all of the data that I can, and then all of the algorithms that I have can tap into all of that data at once. So how would we program such a thing? So the idea is that if I have a foot switch controller, I can have several different foot switches, and they can all enter into different modes, such that immediately when I go into that, I have at hand the mechanisms that will recognize what I'm trying to do. So in play mode, I'm just playing the guitar. In iterate mode, I would be navigating to the different choices of things that I can have, and then I could select something. Once I select that thing, then I would insert something or delete something or move something. And at the point that I need to choose, I want to enter this kind of algorithm or this one or that one. And effectively, that's the point at which we use data entry techniques to navigate a wide space that can be played in a very, very short thing. So a sequence of 2 chords contains quite a lot of information to navigate a quite wide set. So what that would be like is we have a scenario here where I might enter into program mode, iterate and select a connection in the graph in between the guitar and the output, insert an algorithm, play something that picks a pitch shifting algorithm, then go into an entry mode that says, well, I want to pitch shift by 12 semitones, and then exit to playing mode, and now I have a pitch shifter. With the added bonus that if I change just one of those things, I could have inserted a different one on every single string, or I could enter a chord as the amount of transposition, which then makes all of the strings different amounts of transposition. So at that point, we have programmed the pitch shifter in relatively few actions, if I can make that work properly. In addition to that, the intention is to have a gesture mapping mode, because what we want is for this to be useful to the expert player, so to speak, and therefore they are things that are going to be more useful to them that may end up being more complex, which means that we could select a segment of code and then map it to something that becomes a riff or a pattern for recall, and then build our own vocabulary so that over time it becomes richer and richer. So what next? Well, my next trick is to launch a technology probe study in a matter of days, possibly 2 weeks, to effectively seek out of people what kind of interaction, what kind of thinking models they have when they engage with a system that is programming by playing, and then to build up a prototype system for evaluation by performers. So I'm going to be one of those, but I'm going to invite other performers to interact with that. If anyone's interested, that QR code sends me an email, and you can just write, I'm interested in participating in your study, and then I'll send you all of the information, something you can do at home with your computer, and it's going to be really tremendously useful to me, so thank you very much in advance. And here's a bunch of references for things that I have discussed in there, and thank you for listening, and I've been given funding, so thanks for the funding. All right.
Great stuff, yeah, questions. It's almost too much. This is brilliant, isn't it? I'm loving this.
Come on, any questions?
Yeah, come on.
Thank you for that. It's a really good presentation. I'm also a PD lover as well. It's all great. So are you just getting things in my head like, so are you using, you'd be selecting parts of the algorithm by different pitches on the guitar, is that right?
Not just pitches, but yes, in essence, it's going to start by symbolic representation. So if you're thinking a specific pattern of notes might recall something,
yeah.
the intention is that as long as that's enough information, that would be what recalls it.
Cool, cool. And you're you're recording audio into PD as well as sending MIDI data out as well to some other devices, or?
Well, the entry of data, which I didn't discuss in depth because it would take a little bit. The idea is that effectively, sometimes we want to enter just very precise numeric data, like the number 7 or 100 or something like that. Sometimes what we want is something that might be a rhythm. Sometimes what we might want is a structure like a chord. So the idea is that I'm going to have one means that allows you to record what you've just done and map it to a data translator, or to actually capture the symbolic data and then use that immediately. If we record the data, that means that we can use it in several different ways, and that we can refine or tweak what the data translation is of that. So an example of that is if we want different pitch shifters on different strings, one way to do that is to play one chord and then play another one and say the difference between those two is what I want on each string. But we need to have a mechanism that allows that. So right now I'm shifting the problem of this to the data entry mechanisms, which can be a collection that goes at the front.
Really cool. It's a great project.
Thank you.
Play.
Hi. I was wondering, well, I have 2 quick questions. I hope that's okay. The first one is your system different to the code clavier in that some of what you play to control the system are not actually being put through to the amplifier as sound? So is the guitar muted sometimes when you're programming instead of playing?
In my system, the main difference is that when we enter programming mode, we would not be hearing what is happening. Such that effectively, if I learn riffs that are not musical at all, but they are good haptic means of producing and recalling accurate information, that would be it. With the notion that there's no reason why the two could not coexist. So I'm envisioning a scenario in which sometimes it would be possible that we actually decide that thing we're doing is audible. But I'm starting with the notion that I have more usable flexibility if we can't hear it, than I have means to fill it in the silence in between.
Yeah, and the second question is, in addition to, or perhaps besides programming by playing the guitar, have you also considered methods of programming while playing the guitar? So you still keep playing what you would be playing otherwise, but you add controllers that are additional to the guitar. So the history of the guitar has had things like, you know, tremolo arms and wah pedals and all these additional controllers added to do something extra while you can still do what you've been doing so far.
I have considered that very seriously, and I have decided that the constraints of the design space needed to keep the guitar as intact as possible. So other than the fact that in my version is going to be a electronic pickup because I know that, then the guitar is not otherwise changed. I don't want to add things to the guitar, so that effectively the means of controlling is still to the guitar. So right now they are MIDI foot controllers, but they could be anything else. So in my mind there are going to be accelerometers and gesture sensors and things. But I don't want to complicate the problem at this point, and it complicates also the studies with participants if they need to have things that wouldn't otherwise happen.
Brilliant. We are at time. Thank you so much.